Hello students, we will discuss some important JEE questions from basic mathematics. So already we have discussed some 17 questions in last lecture. Now in this lecture we will start from question number 18. So question number 18 is the polynomials p of x equal to kx cube plus 3x square minus 3 and q of x. Q of x is another polynomial which is equal to 2x cube minus 5x plus k. When divided by x minus 4 leave the same remainder, the value of k is. So all of you might have studied in lower classes how to find a remainder when you divide a polynomial by a linear polynomial. You are dividing by a linear polynomial, then it is very simple. You equate the divisor to 0. So in this case divisor is nothing but x minus 4, and when you equate divisor x minus 4 to 0, you will get x equal to 4. Now to find the remainder, you can substitute x equal to 4 in both the expression. Now remainder is same in both the cases. So if you do it, you will get k into 4 cube plus 3 into 4 square minus 3, and that will be equal to 2 into 4 cube minus 5 into 4 plus k. Okay, then if you simplify, 4 cube is 64 into k, 64k you will get, plus 3 into 4 square, that is nothing but 48 minus 3, and then 4 cube is 64 into 2, 128 minus 5 into 4 minus 20 plus k. Okay, now if you transpose k to left hand side, so you will get 64k minus k, and that will be equal to 128 minus 20, 108, and this is 45. So 108 minus 45, that is nothing but 63. So you are getting 63k equal to 63. Then if you divide, k will be 63 by 63, it will be 1. So it will be option number B. Okay, then next question is question number 19. So in question number 19, we have to solve this equation. So we have to solve. So the equation is absolute value of 4x plus 3 plus absolute value of 3x minus 4 equal to 12. Okay, so whenever you have questions related to absolute value or modulus, then first of all you should equate the expression present inside the absolute value to 0. So when you equate 4x plus 3 to 0, and you should also equate 3x minus 4 to 0, so you will get x equal to minus 3 by 4 and you will get 4 by 3. Okay, now if you plot these two numbers on the number line, so you have minus 3 by 4 and you have 4 by 3. So there are three part actually. One part is 4 by 3 to infinity, another is minus 3 by 4 to 4 by 3, another is minus infinity to minus 3 by 4. So we have to take all the three cases. So we'll take case number 1. So in case 1, x would be less than minus 3 by 4. So when x is less than minus 3 by 4, then what will happen? Both will be negative. Are you getting it? Why both will be negative? Because minus 3 by 4 you got with the help of 4x plus 3. So if you take any value of x which is less than minus 3 by 4, both 4x plus 3 as well as 3x minus 4 will be negative. So then absolute value of that, whenever x is negative, then absolute value of x, you know, it is equal to minus x if x is negative. So in this case both will be negative, so you will get minus 4x plus 3 and you will also get minus 3x minus 4. And it will be equal to 12. Now if you simplify, so minus 4x minus 3x, you will get minus 7x, and then you have minus 3, and then you have plus 4 and equal to 12. So if you transpose this constant, this is nothing but plus 1 to right hand side, so it will become 12 minus 1, that is nothing but 11. So you are getting x equal to 11 by minus 7 or minus 11 by 7. Okay, then we need to check whether it is satisfying this condition. So what is this condition? X is less than minus 3 by 4, and this is true. This is less than minus 3 by 4. Yeah, because minus 3 by 4, after that what will come here? Minus 1 will come, and minus 11 by 7, it will still come here between minus 1 and 2. So this is right, x equal to minus 11 by 7. Now after this, either we can go directly for option number C, because only option number C is having x equal to minus 11 by 7. Still, if you want to solve, you can solve it. You can consider case 2 and case 3. But in this question, because the options are in such a way that we can filter the options just after solving one case. So otherwise, if you want to solve case 2 and case 3, I will do it. So case 2, x will be between minus 3 by 4 and 4 by 3. So in this case, as you can observe, because x is greater than minus 3 by 4, then look, minus 3 by 4 you got by equating 4x plus 3 actually. So 4x plus 3 would be positive. Are you understanding it? Or what you can also keep in your mind, that these are like a reference point. So minus 3 by 4 is a reference point for 4x plus 3. So if it is on the left of minus 3 by 4, then it will be negative. If it is on the right of minus 3 by 4, if it is on the right of minus 3 by 4, then 4x plus 3 will be positive. Now for 3x minus 4, the reference is 4 by 3. So if it is on the right of 4 by 3, it will be positive. If it is on the left of 4 by 3, it will be negative. So here when x is less than 4 by 3, means over here, so for this it will be negative because it is on the left of 4 by 3, and this will be positive. So absolute value of 4x plus 3 will be 4x plus 3, but absolute value of 3x minus 4 will be minus of 3x minus 4 and equal to 12. Now if you simplify 4x minus 3x, it will be x, and over here you are getting 3 plus 4 7, transpose 7 to right hand side, so we will get 12 minus 7 5. Now we need to check whether x equal to 5 is satisfying this condition. So it is not satisfying. 5 doesn't fall in this range, right? Because 5 will be on the right of 4 by 3, so it is not between these two values. So then this can't be the solution. Yeah, and the previous one, it was correct, and that was the solution. Similarly, we can do case number 3. So in case number 3, we will take x greater than 4 by 3. So if we take x greater than 4 by 3, then greater than 4 by 3, so if you see this region, then it is on the right of 4 by 3. With reference to or with respect to 4 by 3, it is on the right. Even with respect to minus 3 by 4 also, it is on the right. So both will be positive. So if both are positive, then absolute value of 4x plus 3 will be 4x plus 3, and absolute value of 3x minus 4 will be 3x minus 4, and it is equal to 12. So when you solve it, 4x plus 3x will be 7x, and then 3 minus 4, it is minus 1. So we will transpose minus 1 to right hand side, it will become plus 1. So 7x equal to 13, then x will be nothing but 13 by 7. Now we will check whether it is true. So yes, 13 by 7, it is close to 2, it is greater than 4 by 3. So this is also correct. So at the end, these are the solutions: x equal to minus 11 by 7 and x equal to 13 by 7, which we have got earlier also, option number C. So this sum you could have done just by taking case 1, which I have explained earlier. Okay, now we will discuss question number 20. The number of real roots of the equation absolute value of x square minus 5 times of absolute value of x plus 6 equals to 0. So here, if you want, you can take absolute value of x as y, or without taking anything also, you can split the middle term. It is like a quadratic equation in terms of absolute value. So to split the middle term, you know the method. First you multiply the extreme terms. So when you multiply extreme terms, so 6 into absolute value of x square, you will get 6 into absolute value of x square. Now 6, what are the factor? Either it can be 2 into 3, or it can be 1 into 6, or it can be minus 2 into minus 3, or it can be minus 1 into minus 6. Now we have to select the number which will satisfy this condition, minus 5. So minus 2 plus minus 3, sum of minus 2 and minus 3 is minus 5. So we will split minus 5 into absolute value of x as minus 2 absolute value of x minus 3 absolute value of x plus 6 equals to 0. Now we will group it. So we'll group first two terms and then last two terms. Now between first two terms, what is common? If we take absolute value of x common, we'll get absolute value of x minus 2. Now between the last two terms, if we take minus 3 common, we'll get again the same factor. And this is the rule also for factorization. We should get the same factor. Now one of the factor we are getting is absolute value of x minus 2. Another factor we are getting absolute value of x minus 3 equals to 0. Okay, then we will get, if we equate absolute value of x minus 2 to 0, we'll get absolute value of x equal to 2. If we equate this factor absolute value of x minus 3 to 0, so we'll get 3. Then x will be nothing but plus minus 2. So plus minus 2 means either 2 or minus 2, or when absolute value of x is 3, so we'll get x equal to either 3 or minus 3. So we are getting total 4 values. So it will be option number D. Okay, this sum we can also do in a different way. So I will tell you the different method or way by which we can do it. Suppose you take y equal to absolute value of x. So then the equation will become y square minus 5y plus 6 equals to 0. So either by factorization you will get it, or another method could be, you know alpha plus beta and you know alpha minus beta. So if you apply the formula, alpha plus beta is minus b by a. So here if you compare the coefficient, so a is 1, coefficient of y square, b is minus 5, coefficient of y, and c is constant term 6. So alpha plus beta you will get minus of minus 5 by 1, a actually, so that is 5. Then alpha into beta you will get 6 by 1, that is 6. So what you are getting here, alpha plus beta is positive as well as alpha into beta is positive. Now guys, whenever product of two number is positive, so when product of two number is positive, either both are positive or both are negative. So if both are negative, then sum of two negative number cannot be positive. It means both has to be positive. Now if both are positive, then for absolute value of x you are getting 2 values. Then for x you will get 4 values. The reason is because when absolute value of x is having just one value, suppose 2, then for x you get 2 different values. Similarly, for 2 values you will get 4 values. So that way also we can tell the answer. Okay, next question number 21. The value of greatest integer function of pi minus greatest integer function of minus e is, where greatest integer function, this denotes greatest integer function. So first of all, while doing this sum, we should know what is pi and what is e. So pi is approximately 3.14 and e is approximately 2.718. Now when we plot this number on the number line, so 3.14, it is between 3 and 4. So greatest integer function is always previous integer. So for 3.14, what is the previous integer? It is 3. Next you have suppose minus 3 and minus 2, and you have here minus 2.718, which is between minus 2 and minus 3. Now what is the previous integer here? So for this the previous integer is minus 3. So that will be greatest integer function. So for the first one, greatest integer function 3, for second one minus 3. Now here minus minus will become plus. So it will become 3 plus 3, and that is nothing but 6. Okay, then next question, you have 3 to power 2 log x base 3 minus 2x minus 3 equals to 0. Then the number of values of x satisfying the equation is. So we have to solve this question. So first of all, we can use the properties of log. So 2 log x can be written as log x square, because this number which is outside, it will become the power using the laws of log, because you have studied log a to power n, and that's nothing but n log a. Now converse is also possible. N log a can be written as log a to power n will become the power. So I want to apply the same rule. Okay, now for log, when a log term is defined like this, log x base 3, log x base 3 is defined if x is positive. So that is the first condition. Then next it will become 3 to power log x square base 3 and minus 2x minus 3 equals to 0. Okay, next 3 to power log x square base 3, it will become x square. So why it will become x square? I will tell you using the law which is a to power log n base a. It is nothing but n. So using that, if you observe here, then a is nothing but 3 and in place of capital N you have x square. Okay, now next we can factorize it by splitting the middle term. So to split the middle term, we need to multiply the extreme terms. Extreme terms means first and the last term. So if we multiply, we'll get x square into minus 3. Now minus 3, we can split it as, for minus 3 there would be a multiple way. So either it would be 3 into minus 1 or it would be minus 3 into 1. But we want minus 2. So minus 3 plus 1 will give us minus 2, because 3 minus 1 will give us 2 plus 2. So we can split it as minus 3x plus x minus 3 equals to 0. Okay guys, now you can solve this question by factorization. But suppose if you want to find x, then factorization will take another 2 steps. So without finding factors, we can find the values of x. I will tell you the method how to find out. So x would be nothing but, just observe the coefficient of x. So there are two coefficients, one is minus 3 and another one is 1. Another one is 1 into x. So coefficient is 1. Okay, and then you should observe the coefficient of x square, which is 1. So take the coefficient of x and put the minus sign before it, divide by coefficient of x square. So if you do it, then you will get 3 or minus 1. Even if you do factorization, you will get the same number. Now as you know, x has to be positive, then x cannot be minus 1. So our final answer is x equal to 3. Okay, so then the number of values of x satisfying. So how many values of x we got? 1. So it will be option number B. Okay, next question, question number 23, number of real solution of the equation. So you have square root of log minus x base 10 equal to log root x square base 10. So first of all, you should know what is root x square. So root x square, it is not x, but it is absolute value of x, because square root of any number cannot be negative. So that is the reason why we put this absolute value sign. Okay, so now this and for log is defined when this will become log of absolute value of x. Now absolute value of x, when it is defined, it is so log of absolute value of x base 10, it will be defined when x is not equal to 0, because whether x is positive or negative, absolute value of x will be positive only. Then we should think about this term. So log minus x base 10, it is defined if, so log is defined only for positive number. So here in place of x, we have minus x. So minus x should be greater than 0. It means x should be less than 0, because when you multiply both the side by minus 1, then this sign of inequality will change. Okay, so x is less than 0. Now guys, when x is less than 0, then mod x is nothing but minus x. So this root x square, which is nothing but absolute value of x, and because x is less than 0, it will become minus x. Okay, then the question will become log minus x square root, and it will be equal to log minus x. Okay, now for a moment, if you take, let y equal to log minus x base 10, then the question will become root y equal to y. Now if you do the whole square on both the side, so you will get y equal to y square. Now if you transpose y to right hand side, so you will get y square minus y, or if you take y common, y into y minus 1 equal to 0. So there are two factors here, y and y minus 1. So when you equate y to 0, you will get y equal to 0. When you equate the other factor to 0, you will get y equal to 1. Now this is nothing but log minus x base 10. So when you remove the log, then minus x will be equal to 10 to power 0 or 10 to power 1. So minus x would be nothing but 10 to power 0 or 10 to power 1. Then x would be nothing but 10 to power 0 is nothing but 1. So x would be minus 1 or minus 10. Now at the end we have to check, because this was the condition, x less than 0. Now both the values are less than 0. So it is fine. So how many real solutions we are getting? Exactly 2. Because 2 values we got, and both of them are satisfying the equation. So exactly 2. Okay, then we'll discuss question number 24. So question number 24 is, if x minus 1 into x plus 1 into x minus 2 whole square into e to power 3x minus 1 divided by x into 3 minus x whole cube into x minus 1 whole square into x plus 3 less than equal to 0, then the complete solution set of values of x. So this is inequality question where we have to find inequality. But first of all, we need to simplify certain terms. So x minus 1 is present in the numerator as well as it is present in the denominator. So we have to cancel it. But while cancelling it, you should also know that we can cancel, suppose you have xy x square. So you can cancel it only if x is not equal to 0. So similarly over there, if you cancel x minus 1, then you should write it over there that x minus 1 can't be equal to 0. And anyway, we should also know that whenever any term is there in the denominator, so that denominator term can't be 0. So x plus 3 cannot be 0, x minus 1 cannot be 0, 3 minus x can't be 0, x cannot be 0. So we should know all those things. Okay, so when we simplify, we will get here x plus 1, then we'll get x minus 2 whole square, we'll also get e to power 3x minus 1 divided by, now over here if we take minus sign common, because I will show you separately. So 3 minus x whole cube, if you take minus sign common, you will get minus 1 into x minus 3 and then the whole thing whole cube. So minus 1 whole cube, that will be nothing but minus 1 and it will be into x minus 3 whole cube. Okay. Now, so we will get minus sign. Now, if we want to remove the minus sign, then we need to multiply both the side by minus 1, or we can directly transpose minus sign to the other side, then this sign will change actually. So either I will show you the steps. So we took minus sign outside, so it is like minus x into x minus 3 whole cube, then x minus 1 whole square into x plus 3. Now either you multiply both the side by minus 1, or if you don't multiply, then just transpose the minus sign to the other side. So this sign will change. So it will become x into x minus 3 whole cube into x minus 1 whole square so this will be greater than equal to 0. Okay, now when you equate all this factor to 0, when you equate all the factor to 0, so when you equate this to 0, you will get yeah, and we should not equate these to 0. Yeah, we shouldn't equate these to 0. Yeah, because x cannot be actually, so yeah, numerator term can be equal to they can be equal to 0. So when we equate x plus 1 to 0, we'll get x equal to minus 1. When we equate x minus 2 to 0, we'll get x equal to 2. Next, when we equate e to power 3x minus 1 to 0, so we'll get e to power 3x equal to 1. So we'll get 1 can be written as e to power 0. So if we compare it, then we'll get x equal to 0. But the problem is, if x is 0, then at the same time this will also become 0. So 0 by 0 will be undefined. So even though it is in numerator, but the value which we are getting, it cannot be 0. It is not possible. Okay, so we are getting a special case, like at x equal to 0, even this term is 0 and that term is 0, but we can't cancel it also directly. Okay, so we have to think about this also. Now when we equate the denominator term to 0, so we'll get x equal to 3, but denominator cannot be 0, so we should write not equal to. So it means x cannot be equal to 3, x cannot be equal to 1, x cannot be equal to minus 3. And even x cannot be equal to 0, which we have got over here when we equated these two to 0. Okay, then yeah, now we need all these values. So we need all these values. Generally for inequality, we should equate everything to 0, and we need all these values, because all these values, they will play a very crucial role when the sign will be decided. So when you plot all these points, so first you will plot the smallest one, which is minus 3, then minus 1, and then you have 0, 1, 2, 3. So you have minus 3, you have minus 1, you have 0, and then you have 1, you have 2, you have 3, and at last you have infinity. Okay, so when you have x great, yeah, first of all, we always start from the rightmost. So this is the rightmost part, right? There are so many parts, like this is one part, this is one region, this is another region, this is another region, but we always start from the rightmost region or part, where the sign will always be positive. Blindly you can put positive sign. After that, sign may change. We go from right to left actually. We start from the rightmost and we go towards left. Then after every root, suppose after this is the next interval, we should think, so we crossed which root? X equal to 3. Now x equal to 3 came from this actually. It came from this. And what is the power of this? 3, which is odd. So whenever the power of the factor from which this value came or root came, if it is odd, then sign will change. So sign will change here, it will become negative. Now 2 came from, yeah, and we should also cancel this one, x minus 1 and x minus 1 whole square. So yeah, we cancelled here, then yeah, we should remove this power. Okay, so 2 is related to this and it is having whole square. Whole square means power is even. So power is even, it means sign won't change. So it was negative, now also it will remain negative only. Okay, then about 1. So we'll have a look at this. So 1 came from x minus 1. Power of x minus 1 is 1, which is odd actually. So odd means sign will change, so it will become positive. Okay, then next, about 0 we need to check, right? So 0 is related to both actually, e to power 3x minus 1 by x actually. So over there we need to put the sign actually, e to power 3x minus 1 by x. So when x is positive, that time what is the sign? if we put x greater than 0, then e to power, whenever you have a small positive number also, like if you put 3 into 0.0001, so this will also be greater than 1, minus 1, so it will be positive by, if x is very small number also, it is positive only, so positive by positive it will be positive. But suppose if you put just after 0, because next we have to think about this interval where x is slightly smaller than 0, or in this interval, yeah, we can take minus 1 by 2, like that also. So if you take x equal to, suppose minus 1 by 2, so it will become minus 3 by 2. If you put x equal to minus 1 by 2, you will get e to power minus 3 by 2, and that will be less than 1. So because of that, the numerator will become negative and denominator is also negative. So negative by negative will get positive actually. Is it clear? So we are getting negative by negative, which is nothing but positive. So if it is positive, then, so basically sign is not changing about 0 then, because both sides you are getting positive only. Next we should think about minus 1. So minus 1 came from x plus 1, and power of x plus 1 is 1, which is odd, so again sign will change. Then minus 3 came from x plus 3, and power of x plus 3 is odd, so again sign will change. Okay, then finally what is the sign here? Greater than equal to 0. Greater than equal to 0 means positive and equal to 0. So it is equal to 0 at minus 1 and 2. Other points they won't be included, and positive, then these are the reason. One is this minus infinity to minus 3, another is minus 1 to 1. But in minus 1 to 1 also, x can be equal to minus 1, but it can't be equal to 0. So that we have to be careful about. And then this is another reason. So at the end, the solution is x belongs to open interval minus infinity, open interval minus 3 also, because only these 2 points are included. So we should be careful. Union, now closed interval minus 1. Okay, and then yeah, so in some options like you have minus 1 to 1 and 0 is subtracted, excluded, so we can go for such kind of options. So we can take minus 1 to 1 where 0 will be excluded, and we can keep 1 in the open interval because 1 is also excluded. So minus 1 closed interval, 1 open interval, union. Next would be, and 2 is also included. So even though this, it doesn't come under positive reason, but this value will be there. So union, and then we also have this reason 3 to infinity, that will be open interval. Union, we will have 2 in flower bracket, minus we will have 0 in flower bracket. Okay, so it will be option B. That would be the correct option. Okay, now we'll discuss. So all of you, first of you can understand this, what I have done. So first of all, you equate everything to 0. These are the point you will get about which you will do the inequality. Then everything I explained, you have to start from positive, then sign will change. If the root came from a factor which will have odd power, and sign won't change if the root came from a factor which is having even power. So you should understand. Now we'll do question number 25. So in question number 25, a and b are a real number for which 60 raised to power a is 3 and 60 raised to power b is 5, and then you have to find 12 raised to power 1 minus a minus b divided by 2 times of 1 minus b. Now this question we can do it by exponents, laws of exponents, as well as we can do it by log. So if we do it with the help of laws of exponent, then 12, because over here if you can observe 60, so I think this question is related to 60 because 60 is present in 2 different places. So 12 can be written as, first of all, 60 by 5. Or so first of all 12, that is nothing but 60 by 5. So you will write 60 raised to power 1 divided by 5. 5 is nothing but 60 raised to power b. So it will become 60 raised to power 1 minus b. Is it clear? Okay, then you will get, in place of 12 you can write 60 raised to power 1 minus b raised to power 1 minus a minus b raised to power divided by 2 into 1 minus b. Then when you multiply these two power, 1 minus b will get cancelled. So you will get 60 raised to power 1 minus a minus b divided by 2. Okay, now we can write this part as 60 raised to power 1 minus a minus b, then the whole thing raised to power 1 by 2. Now we can write 60 raised to power 1 minus a minus b. So the positive power will be in the numerator using laws of exponent. The negative power, it will be in denominator. So it will be like 60 raised to power a into 60 raised to power b, and then the whole thing raised to power 1 by 2. Okay, now you also know 60 raised to power a. 60 raised to power a is nothing but 3, and 60 raised to power b is 5. So you will get 60 divided by 3 into 5 raised to power 1 by 2. So you will get 60 divided by, this is nothing but 15, 4. So 4 raised to power 1 by 2. Power 1 by 2 means square root. So square root of 4, that is nothing but 2. So it will be option number A. Okay, another method for this question is by logarithm also we can do it. So if we do it by logarithm, then we need to find the value of a and b. So 60 raised to power a is 3. So if we take log 60 raised to power a is 3, then if we take log, so whenever you take the log, then this base can be the base of the log. Yeah. So using this, you can say that a will be nothing but log 3 base 60, because if a is log 3 base 60, so when you remove the log, then 3 will be equal to 60 raised to power a. Similarly, you have 60 raised to power b equal to 5, so you will get b equal to log 5 and base 60. Now you have to simplify this. 12 raised to power 1 minus a minus b divided by 2 into a minus b. So first of all, you simplify 1 minus a minus b. So 1 can be written as, because we want to make the base equal for simplification, log 60 base 60 minus a, that would be log 3 base 60, and then b would be nothing but log 5 base 60. Now if you simplify using log, you will get 60 will be there in the numerator, other to the minus term it will come in the denominator, so it will be like 3 into 5, so it will be 4. So log 4 base 60. Then we should calculate 1 minus b. So 1 is nothing but log 60 base 60, and b is nothing but log 5 base 60. Okay, then you will get log 60 by 5 base 60. So it is log 12 base 60. Okay, then we have to simplify. Now first of all, we need to calculate this. So 1 minus a minus b divided by 2 times of a minus b. Now we have calculated 1 minus a minus b, it is log 4 base 60 divided by 2 times of log 12 base 60. Now this number 2 which is outside, it will become the power of 12. So it will become log 4 base 60, and then you will get log 12 square, that is nothing but 144 base 60. Now whenever base is same and you have log 4 by log 144, it can also be written as log 144 log 4 and base 144. Okay, and then you have 12 raised to power this. Okay, so or we could have left this as 12 itself. We could have kept this as 12 itself. So this was like 12 square, and maybe you could have written this as 2 square. So I will tell you what would be the use of it. So first of all, you will get log 12 square and log 2 square base 12 square. So whenever power is same, you can just cancel the power. So then it will become log 2 base 12. Okay, now you have to find 12 to power 12 to power this. Now this power is nothing but log 2 base 12. So it will become 2 using the rule a to power log n base a is equal to n, because here a and a 12 and 12 is same. So this way we are also getting the same answer, but I feel maybe by the laws of exponent it is easier. Okay, then next we will discuss question number 26, number of ciphers after decimal before a significant figure comes in this. So the power is negative. So whenever power is negative, so such kind of number would be like, it would be like maybe 0.000, and maybe there would be so many zeros. After that some significant figure will come. So you have to count number of zeros before first significant figures. So for this also we can do it by logarithms. So I will tell you the method. So first take this number as n or x, anything like that. So if you take this as x, which is nothing but 5 by 3 to power minus 100. Now take log on both the side. So if you take log on both the side, you will get log x base 10 as log 5 by 3 raised to power minus 100 base 10. Now minus 100 is the power which will come out. So it will become minus 100 into log 5 by 3. Log 5 by 3 can be written as log 5 minus log 3. Okay, then log 5, or before simplifying all itself, we could have multiplied both by 2. So if we multiply both by 2, we will get log 5 into 2, 10 divided by 2 into 3. Okay, then minus 100 into, you will get this as log 10 and then minus log 2 minus log 3. So you are getting here log 10, then minus log 2, and then you will get log 3. Okay, then log 10 base 10, that would be nothing but 1. Then log 2, it is nothing but 0.301. Log 3 would be nothing but 0.4771 or 477 approximately. Now if you add them, both are negative, they will get added. So 301 and 477, their sum would be nothing but 778. So if you subtract, I think you will get minus, you will get plus 0.222 approximately. So if you multiply, you will get minus 22.2. So then we should take greatest integer function of this. So greatest integer function of this, suppose that is represented by n. So n is greatest integer function of minus 22.2. Now minus 22.2, if you plot on the number line, it is between minus 22 and minus 23. So the left side of this is nothing but minus 23. So you will get minus 23. So you're getting minus 23. So yeah, now you compare this with minus n. So n will be nothing but 23. Now number of ciphers, the formula is, it will be n minus 1. So 23 minus 1, it would be 22. Yeah, so you should understand, first of all, after taking log, we should find greatest integer function, which is minus 23, compare it with by some negative integer minus n, then n will be 23, then number of ciphers will be nothing but n minus 1, which is 22. So it is option number B. Okay, then question number 27. For defined values of ABC expression, 1 by log ABC root BC, then log ABC base root CL, then log 1 by log ABC base root AB. So whenever log is there in the denominator, if we take it to the numerator, then this ABC will become base, and so they will interchange their places actually. Okay, so you will get log ABC will be base and you will get root BC. You get root CA, and then you will get like this: log root BC base ABC, log root CA base ABC, log root AB base ABC. So base is same, then you know log M plus log N plus log P, it will be like log M and P. So you will multiply this root BC, root CA, root AB. So you will get ABC. So you will get log ABC base ABC. So it will be nothing but 1. Whenever both are same, like log X base X, so it will be 1. Similarly, log ABC base ABC, that will also be 1. So it will be 1, option B. Okay, now we'll discuss question number 28. The value of 3 to power log 5 base 4, then 4 to power log 3 base 5, minus 5 to power log 3 base 4 and 3 to power log 4 base 5. So we have done a similar question in lecture 1. So 3 to power log 5 will be equal to 5 to power log 3, because base is same in both the cases. So there is a rule. According to that rule, a to power log b is equal to b to power log a, if base is same for both. So by that rule, these two terms will get cancelled. So these 3 to power log 5, 5 to power log 3 will get cancelled. Similarly, 4 to power log 3 and 3 to power log 4, that will also get cancelled. So then answer would be 0, first option. Okay, then question number 9, we have to find log b base a, where b equal to 12 divided by 3 plus root 5 plus root 8, and we have a equal to root 1 plus root 2 plus root 5 minus root 10 is. So first option a negative integer, second option a prime integer, third option a positive integer, fourth option an even natural number. So first of all, we will simplify this, because this is already simplified, but here we have some terms in the denominator. So by rationalization, we can simplify b, and then we will get the idea how to do it further. So when we rationalize, we need to multiply the denominator, which is 3 plus root 5 plus root 8. There are two irrational terms. So we just need to change the sign of any one term. Either we can change sign of plus root 5 or plus root 8. So I will change the sign of plus root 8. So we need to multiply both numerator and denominator by 3 plus root 5 minus root 8. Okay, so if we multiply the numerator, we'll get 12 into 3 plus root 5 minus root 8 divided by, in the denominator you can consider 3 plus root 5 as a, then root 8 will be b. Similarly, this is a, then that is b. So it will become a plus b and then a minus b. So a plus b into a minus b, you know it's a square minus b square. So 3 plus root 5 whole square minus root 8 whole square. So you will get this, and then divided by 3 plus root 5 whole square. So 3 square would be nothing but 9, root 5 square will be 5, 9 plus 5 14, 14 plus you will get 6 root 5, and then root 8 whole square, that would be 8. So 14 minus 8 6, so then you can take 6 common. So you're getting 12 into 3 plus root 5 minus root 8 divided by 6 into root 5 plus 1. Then multiply both numerator denominator by root 5 minus 1. So we are rationalizing this root 5 plus 1. Now first of all we can cancel this, so by 2 times. So we are getting 2 into, now we need to multiply each and every term. So 3 into root 5, then 3 into minus 1. So if we multiply 3 into root 5, then minus 3, because we are multiplying 3 by minus 1. Then next root 5 into root 5, that will be nothing but 5. Then next root 5 into minus 1, so that will be minus root 5. Then next minus root 8 into root 5, so that will be minus root 40. Then next minus root 8 into minus 1, so that will be plus root 8, divided by, it is in the form of a plus b into a minus b, so it will become a square minus b square. So root 5 whole square minus 1 square. So 5 minus 1, it will be 4. Okay. Now over here we are having 3 root 5 minus root 5, so that will be 2 root 5. Then minus 3 plus 5, that will be 2. Then root 40 is like 4 into 10. So you know root 4 is 2, so 2 root 10. Okay, then root 8 is like root 4 into 2. Root 4 is 2, so it will become 2 root 2. Root 4 is 2, and then this 2 will be left, so it will become 2 root 2. Divided by, you are getting 4, because root 5 square is 5 minus 1 4. Now you can take another 2 common from here. So 2 is already there, you take another 2 common, you will get root 5 plus 1 minus root 10 plus root 2, divided by, you are getting 4. So 2 into 2, 4 and 4 will get cancelled. Then you are getting nothing but, if you just rearrange the term, if you rearrange all these terms, like 1 you can write it as root 1, then you have root 2, then you have root 5, then you have minus root 10. So what you are getting, that is nothing but a. If you observe here, so at the end you got b equal to a. So if both b and a are equal, then what will happen to log b base a? It will be 1, because in place of b you can substitute a. So log a base a, it will be nothing but 1. Okay, now we will do question number 30. If log q base p plus log r base q plus log p base r vanishes. Vanishes means it disappears, so it is 0, like nothing will be remaining. Vanishes means basically in mathematics 0, where p, q and r are positive real numbers different from unity. They are not 1, because if they are 1, then log won't be defined, base can't be 1. Then the value of, you have to find the value of log q base p whole cube, then log r base q whole cube, then log p base r whole cube. So we can first of all assume that let a equal to log q base p and b equals to log r base q and c equals to log p base r. Now sum of these three terms is 0. Now these are nothing but a, b and c. This is 0. Now these are nothing but a, b and c. So a plus b plus c equals to 0. Next we need to find the sum of their whole cubes. So you know that they will be like a cube plus b cube plus c cube. So if a plus b plus c is 0, then a cube plus b cube plus c cube, it is nothing but 3abc. Then in place of abc, we can substitute this. So 3 times of a is nothing but log q base p. Now log q base p can also be written as log q by log p, where base can be anything else. Even if you don't put the base, no problem right now. So then similarly b is nothing but log r base q, that can be written as log r by log q, and you will also get log p base r, that is nothing but log p by log r. So then if you multiply, so log q will get cancelled, log r will get cancelled, and then log p will get cancelled. So at the end what is left? 3 is left. So 3 is nothing but an odd prime number, because it is not even prime, it is not odd composite, it is not irrational. So it is an odd prime number. Okay, that's it student. Thank you for watching.